Hello everyone and welcome to Abaqus FEM. In this video, I'm excited to introduce one of the most comprehensive Abaqus learning packages we've ever developed, the Abaqus Concrete, Steel and Composite Column Analysis package. If you are a graduate student, a PhD researcher, a university academic, or a professional engineer working with finite element analysis, this package has been designed specifically for you. Modern structure engineering is evolving rapidly. Engineers are no longer interested only in simple linear analysis. Today's research focuses on nonlinear behavior, damage evolution, advanced materials, seismic performance, impact resistance, and blast protection. Uh, Developing reliable numerical models for these problems require both theoretical knowledge and practical experience with advanced finite element technical. Unfortunately, finding complete Abaqus example that covers these topics is extremely difficult. Most online tutorials focus on the basic example and rarely explain how advanced research models are actually developed. That's exactly why we created this package. Instead of isolated tutorial, this package contains 36 complete research-based workshops, each inspired by published scientific study and designed to teach professional finite element modeling technical from start to finish. Throughout these workshops, you learn how to simulate reinforced concrete columns, steel columns, composite columns, and innovative structure system using realistic engineering approach. The package begins with reinforced concrete column analysis. You will learn how to model cracked concrete columns reinforced with GFRP bar under cyclic loading. Investigate the confinement effect of hybrid jute and basalt fiber reinforcement polymer on ultra-high performance concrete columns. Strengthen reinforced concrete column using stainless steel plates and simulate CFRP retrofitted columns subjected to seismic loading. You will also perform detailed compression analysis of reinforced concrete column reinforced with GFRP bar and a spiral CFRP confinement while investigating a concrete damage and failure mechanism using the concrete damage plasticity. Uh, the next section focuses on the steel column and steel connections, section B. Here you learn how to analyze concrete in cast steel box column, demountable column to base plate joints, exposed plate with anchor bolts, and advanced steel beam column connections. You'll also study the geometric instability through buckling and post-buckling analysis, investigate the strengthening of corroded steel column using CFRP, and evaluate cyclic behavior, plastic deformation, and damage evolution in various steel structure. The package then moves into one of today's most active research area, composite columns. You'll model wood ultra-performance steel composite column, ultra-performance filled aluminum columns, concrete filled steel tubes, double skin composite columns, rubberized concrete system, steel in cast ultra-high performance column, and many other innovative structure configurations. Several workshops also investigated the performance of composite column and strengthened with CFRP, reinforced with internal steel section, and connected using shear bolted. One workshops even demonstrate how to validate a finite element model against published experiment research, as you can see it here. Uh, Another major strength of this package is its coverage of advanced loading condition. Uh, Instead of studying only static compression, you learn uh, uh, cyclic loading, seismic analysis, dynamic loading, impact simulation, air blast loading analysis, and explosion. Uh, the final workshop introduced two powerful numerical techniques widely used in impact and blast engineering, coupled with Lagrangian method and a smooth particle hydrodynamic model. This technique allows engineers to simulate highly nonlinear events that cannot be modeled accurately using conventional finite element approaches. approaches. The package also covers advanced constitutive material model like this here, for instance, here. We, for high strain rate application involving blast and impact loading, several workshops include implementation of the Johnson-Helmquist or JH2 model for concrete to consider full failure and full damage behavior of the concrete. You can see also here this model. Other workshops include complete CAE file, including you to explore every model in detail directly inside Abaqus. You'll also receive the input file, a step-by-step video tutorial, and whenever available, the original reference research paper is also included, and codes for the material. And at the end here, we have the package price. The price for the package, for the full package, is 156 euros. We accept PayPal, Visa, MasterCard, and all the cryptocurrencies. Before payment, contact us through this email to tell you more about the purchasing process, the payment method, the package content, download link, and everything that you need to know. For now, thank you for your attention.